So let's do kind of a cool project. I've seen some funny memes on Facebook and all different places before where it says if you want to lose weight, the fastest way to do it is to go to the moon. Well, why? Well, the measure of weight depends on gravity, right? How much are you being pulled to the ground? Well, gravity on the moon is totally different than gravity on Earth. So it says because the moon has no atmosphere, a falling object on the moon encounters no air resistance. In 1971, astronaut David Scott demonstrated that a feather and a hammer fall at the same rate on the moon. It's a really, really cool concept. You drop a feather and you drop a hammer at the exact same time, just hold them both and drop them equally, and they will hit the ground at the exact same time. That's because there's no air resistance. It says the position function for each of these following objects is S of t equals negative 0.81 t squared plus 2. So here what I see is there was no initial velocity, he just dropped them. The initial height was 2 feet above the ground, and then the rate of gravity is different, so we have a different leading coefficient in front of t squared. It says where S of t is measured in meters, so we're not, when I said 2 feet, I should have said 2 meters, and t is the time in seconds. The acceleration due to gravity on Earth is 9.8 meters per second. What is the ratio of Earth's gravitational force to the moon's? So to do this, let's find the acceleration on the moon. So we know again that our original function, the position function, is negative 0.81 t squared plus 2. So if we want to find that velocity function, we find the derivative of this. Well, this would be negative 0.81 times the derivative of t squared. Well, the derivative of t squared is 2t, so we do negative 0.81 times 2, which would be a negative 1.62 t plus the derivative of 2, which is 0. Now we want to find the acceleration. The acceleration on the moon then would be the derivative of the velocity function, which is negative 0.162 times the derivative of t. Again, the derivative of t is 1, so negative 1.62 times 1 would be negative 1.62. So there would be my acceleration, and remember this is meters per second squared. So if you want to know the ratio of the two of these, you would have Earth's, which is at a rate of 9.8 meters per second squared, and then you would have the moon. And the moon would be, sorry, and that should be a negative number, negative 1.62 meters per second squared. So what's the ratio of the two of them? Go ahead in your calculator and do negative 9.8 divided by negative 1.62, and you're getting approximately 6 to 1. So what does that mean? That means the acceleration due to gravity on the Earth is approximately 6 times as strong as the acceleration due to gravity on the moon. So that's your gravitational pull, right? So essentially you're saying gravity is 6 times stronger, roughly, on Earth than it is on the moon.